In this video, we'll be discussing what is a pulse transformer and how does their response get varied with respect to some significant parameters. So before we go into the actual discussion, let us know what is pulse transformer. So as the names in mentioned or the name states, so pulse transformer are the one that helps us in providing voltage in the form of pulse to the transformer or for transmission, or in other words we can say it is designed or optimized for giving voltage in a pulses between the two windings of the transformer. So the two windings that is being well connected to the load. So this is how we define the pulse transformer. This the primary use of the transformer is to provide a voltage in the form of pulse between the two windings where we have the entire load that is being connected. So these transformers are helps us in controlling the voltage supply in a device in a systems where we have less power requirement. So this is the one use of our utilization of this pulse transformer. So in other applications can be like it can be used in radar as mentioned in a TV, digital circuits, whatever we have, and many more actually. So the main functions of the pulse transformer are listed below. One thing is that like it can be used to uh, change the amplitude of the voltage. That is the one thing with in a pulse manner. Okay, that is one thing. Second thing is that like the we can change the polarity of the given voltage, whatever obtained thing with respect to the pulse input. Third thing is that like we can couple the inputs and inputs of different transformer and for a multitude application. And fourth thing is that like it can be also used as an isolation transformer. These are the main functions of pulse transformer. And you can see the circuit diagram of pulse transformer both in a non-load condition and in a load condition. The only difference is that we have output load that is being connected to the circuit in case of with load, whereas in case of without load we don't have any load that is being connected, which you can infer from the diagram. As a transform as it is a pulse transformer, you have primary and secondary coil windings that you can see from the figure, and we give inputs to them with the help of AC source. Okay, so in addition to that, this pulse transformer can also be well connected to a any semiconductor device that you can see from the figure where we have diode that is being connected to the circuit. So the same diagram for a load concept, a diode that is being connected, and you have resistance and capacitance that is being connected series and parallel to the diode. The purpose of this thing is that like it is just to show how does a pulse transformer can help us in giving an input voltage to a diode, and how efficiently the voltage that is taken off by the diode. That is a one important criteria for designing such circuit. So you can see every winding whatever we have in this pulse transformer, so includes an equivalent turns, so that like it works as a primary, whereas another that works as a secondary one. So signal whatever that is being given to a diode or the whatever the semiconductor device that we incorporate in our device will be in a ratio of 1:1. And in case of transformer, whereas we have primary and secondary windings, so there the ratio will be of 1:1:1. So the gate signal of firing circuit whatever we have through the pulse transform can be given in the form of voltages, I mean pulsed voltages. So the diode whatever we have here, it is used here to avoid or prevent the reversing the gate current. So third winding of the pulse transformer is also shown over here. You can see from the figure. The design of this transformer can be done with an efficiency. So the primary windings inductance must be high to decrease the magnetizing current. The direct current supplied throughout the primary winding in the transformer can also prevent the saturation of the core. So this is the other one thing. So in addition to that, we may have there is an frequency effect on the output signal. So the output signal shapes and the frequency and the inputs are same for the high signal frequency. So what we can say is that the output is directly proportional to the incorporation of input on the low frequency. It all the whatever the input we give through this pulse generator that has a greater capability to control the voltage, that is, I mean, the input that is being given into the diode. So this is the main purpose of this pulse transformer. And there are certain specification when we talk on this pulse transformer or the significance. So one thing is that pulse amplitude. So what is a pulse amplitude is that it is a highest peak value of a signal apart from the useless peak, I mean useless spikes. So whatever the amplitude that we get in a peak, and the highest value whatever we reach, that we call it as an pulse amplitude. And second one is that it's a rise time, which we define it by TR. So this rise time can be defined as a time that is received by an output signal to enhance it from 10% to 90% of the peak pulse amplitude. So that we call it as a rise time. And third thing is a overshoot. The output signal whatever we get, when it exceeds a peak amplitude, then we call it as an overshoot. So it should not go beyond the highest peak value of the signal. If that case happens, then we call such spectrum as an overshoot spectrum or overshoot signal. And we have one more parameter like pulse width, whereas this is nothing but the interval between the first and the last instance of an amplitude. And we have other parameter drop and fall time. So drop is a pulse amplitude displacement throughout its level, and we also call it as a tilt. And we have one more specification as a fall time. So this is the output signal greatly reduces from 90 percentage to 10 percentage, and this we call it as a decay time. Okay, so these are the certain specification that we need to be followed when we work on this pulse transformer. So with this we'll end up. Thank you.